And good morning, ladies and gentlemen. Today, we are going to be studying the types of molecules and elements. And we're going to be putting all those things kind of together. But we're going to start off with reviewing what we did last class. So let's just take a look at what we did last class. It says, what's the difference between an element and a molecule? So an element, ladies and gentlemen, would be, an element, ladies and gentlemen, would be one atom. So an element would be like one atom, right? Just kind of like boom, an iron atom. Boom, that would be an element. A molecule is made up of two or more. Something like that we had last class, we had something like, you have H2O, so you'd have H, and then you'd have your two O's, right? And it'd be made up of H2O. So it'd be H, and then that looks a little bit better, 2O. All right, so it's multiple atoms put together are molecules. So let's take a quick look down below. You can see here, we have P, which is phosphorus, ladies and gentlemen. Phosphorus, is that an element or is that a molecule? Well, since there's only one, then P is just phosphorus, so that is gonna be an element, and that would just be something like that. It would just be the element of phosphorus. CH4, let's take a look. CH4 is made up, looks like some carbon, and it looks like some hydrogen. Now, are there more than one element there? You can see that there's a capital C and a capital H, so that would be a carbon and a hydrogen. So this is methane, this compound, right? It's made up of CH4. And this would be a molecule because the molecule is made up of more than one compound or more than one element. Excuse me. So if we were going to draw that, we might say that here we go. We have carbon, usually represented by a black element, right? So here we would have carbon, and then maybe going around the outside, we would say we have 4 hydrogens. So we'd have 1, 2, 3, 4, and that would be our methane molecule. NH3, what do you guys think about NH3? Element or molecule? Yep, okay, well, this one is known as ammonia. And ammonia looks like it's made up of nitrogen and hydrogen, okay? And making up both of those, that's gonna make it a molecule because it's made up of more than one thing. And you can see that there is one nitrogen. So there's our one nitrogen. And then it would have 3 hydrogens, looks like going around the side. See if I can put those on. There we go, 1, 2, 3. So that would pretty much be, a ammonia. The last one, calcium. What would you say for calcium? Okay, yep, that's an element because there's only one. It's a element. There's a capital C and a lowercase a, and that usually means that it's an element. So you can see up here that we would have something like, iron. You can see iron is a capital F and a lowercase e. Tungsten is just a capital W, but you can see they all start with a capital letter. But again, we've talked about how to write elements before. So let's take a look at the next page. So on this, let's take a look at how many of each element are in a molecule. Remember, a molecule is made up of more than one thing. So more than one element. So we have sodium, Na, and there's 2 of those. Remember, the subscripts means there's 2. And then we have carbon, and there's 3 carbons. And then we have 4 of these. So let's work with these parentheses right here. So we have Na2, C3, and we're in parentheses. There's 4 of these parentheses right here, which means we physically have 4 of these compounds right here. There's an Na2, C3, an Na2, C3, and another Na2, C3. This 4 means that we have 4 of what's inside the brackets. Now, if we take a look at those 4, how many sodiums would we have? We would have 2, 4, 6, 8 sodiums, and we would have 3, 6, 9, 12 carbons. So let's take a look. So how many of each would we have? Well, we would have 4, and we're going to multiply that through. So it's going to be 4 times 2, so we're going to end up with 8 sodium. And then the number of carbons we're going to have. How many carbons are we going to have? We're going to have 4 times 3. It's going to be 12 carbons. Okay, so I'm going to slow it down a little bit because that was a quick review because we have another opportunity right here. So again, how many of each? Well, how many Ks do we have? So we're going to have 1 potassium. That's a K. And then you can see the next element, there's a capital M. So that's going to be Mn. That's going to be manganese, which is right up here. There's manganese. And how many manganese do we have? We have 1 manganese. Now, some of you might be sitting there saying, but Mr. P, it says there's 4. There's 4. That 4 only goes for whatever it's next to. And it shows that it's next to the oxygen. It's not next to the manganese. And notice, remember, there's no parentheses to distribute that. So that just means there's going to be 4 oxygen molecules. So let's get back and practice another one with parentheses. So we're going to look and we're going to say, well, how many? Well, we see parentheses here. So that means 3 of these CH2s. So each CH2, there's only 1 carbon, but times 3, right? So that's going to be, there's 1 carbon in here, but times 3 is going to give us 3 carbons. And then we have 2 hydrogens inside the brackets. 2 hydrogens times 3 is going to give us 6 hydrogens. And then we're just going to close it out. There's only 1 oxygen here. That 2 has nothing to do with the oxygen. Okay, that 2 is just the hydrogen. So we have 1 oxygen, and that's times 0 equals 1 oxygen. Then we have 2 more hydrogens. So then we have 2 more hydrogens. And if we ask for the totals, then we would get 3 carbons, and then we would have 8 hydrogens total, because 6 plus 2 equals 8. Okay, and then lastly, our 1 oxygen. Okay. Okay, so now what we're going to do is we're going to take a look at different types of elements or atoms. Okay, so first we're going to take a look at metals. Now, what is a metal? We've all seen metals before. Metals, you build buildings with them. Cars are made out of them. You look at the rims on a car. If you just look around you in your room or wherever you are, parts of your computer. So there's lots of metals all around us. All right, so metals generally are solid at room temperature, which means at room temperature, which is where we are right now, 70 degrees or so, metals are going to be solid. The exception of that is liquid mercury. Okay, mercury is a liquid. It's right here, element number 80. All right. Now, liquid mercury, you used to find them in thermometers. Not anymore because it's such a toxic metal. But the reason that it would work, and we'll talk about this later, is that the mercury, when things get hot and they get cold, they expand and they contract. So metals also are very, very shiny. It's another characteristic. So metals are good conductors. Okay, a good conductor would be a good conductor of heat or electricity. A good conductor moves heat or electricity. A couple examples would be a frying pan. You make frying pans out of metal. You don't make a frying pan out of wood. Why wouldn't you make a frying pan out of wood? Well, because the wood would not allow the heat to go through it very well, and you would think it would burn. All right, so you make frying pans out of metal because they are good conductors of heat. Now, also good conductor of electricity. If you look at the wires that you have up above your head that are running electricity, the reason we use metal is because electricity moves through them. All right, and being a wire, these are ductile. Ductile means that this metal can be drawn or formed into long metal into basically wire is what it is. And you can use that to support or to use for electricity. They're also very malleable. You can do different shapes. You can take a look like right down here at the bottom. These pieces of metal are bent. Malleable means you can make different shapes. You can make an airplane wing, and you can make them all different shapes. So metals also, and this is the key, like to lose electrons. They love to lose electrons, and they're MCI. When they are an ion, they are cations. You remember that cations are positive, ladies and gentlemen. Why? Well, let's just take a look at something like sodium. Sodium, which is right here in column number 1, has 1 electron on the outside, and that sodium wants to lose that electron, and in doing so, that sodium will turn into sodium ion with the 8 electrons now in the valence. Losing the electron makes the metals positive. Now you can see that right here on the periodic table. You can see all these yellows right here. All those yellows are metals. And most of the periodic table that you can see is yellow, which means most of the atoms on the periodic table are metals. So now let's take a look at nonmetals. Nonmetals, ladies and gentlemen, are very brittle. What does brittle mean? Brittle means they break. Brittle is stuff like glass. So if you take a piece of glass and you drop it on the floor, it shatters. If you take a piece of metal and drop it on the floor, the metal just kind of clanks. Maybe it bends a little bit, but doesn't shatter or break. So nonmetals are brittle. Nonmetals are also poor conductors of electricity. That's why you don't like making your house out of metal, because the metal, the heat will go straight through. You'll put non-metals up in your attic, and those non-metals are going to help insulate or not allow heat to go through. You can see the non-metals right over here. All right, the non-metals are all in green. You see the green right here? So the green, those are all the non-metals. Hydrogen is a non-metal as well. Non-metals can be a solid, a liquid, or a gas at room temperature. So chlorine is a gas at room temperature. Bromine, which you can see right here, is also a gas, but it can also be, depending on the temperature, because it's pretty finicky, can also be a liquid at room temperature. And then something like iodine up here is a solid. So right here in this column, you can have a gas, a liquid, and a solid in the nonmetals. This is carbon, also a solid. This is sulfur. Sulfur is a yellowish compound that it's kind of stinky. It's the one that kind of has the smelly egg feel to it. All right. And then the last one is phosphorus. You can see this phosphorus is a solid. Now, generally speaking, ladies and gentlemen, nonmetals like to gain electrons. What do we mean by gain electrons? Exactly what it says. They like to take electrons in. Their MCIs, their most common ion, they're anions, which means they're normally negatively charged. For example, if you take a fluorine, fluorine is sitting here with 7 valence electrons, right? Fluorine wants to gain just 1 more electron. So electrons go towards fluorine. Fluorine will pull electrons in, right? And turn into F minus, and that would have 8 valence electrons on F minus. That would be what we have for nonmetals. All right. So next, what we're going to take a look at. So now we have what's called metalloids, ladies and gentlemen. A metalloid is kind of like a half metal, half non-metal kind of feel to it. So a metalloid has properties of both metal and non-metal. It's kind of like a mixture, which is why the metalloids, which are given in purple here, are found right here. And they basically make a little division or a border between the metals and the non-metals. Now, a lot of these metalloids. They conduct electricity, but just barely conduct. Some conduct, some don't, some conduct just a little. And that's why we use these as semiconductors, which is why it's called Silicon Valley. It's called Silicon Valley because computers are made, well, the chips and stuff are made with these semiconductors like silicon and germanium. So if you look, these elements look like metals, right? You couldn't tell the difference. But once you work with them, you'd find out that they are metalloids, that they have different characteristics of both. Now, let's take a look at the periodic table. What does it look like we have the most of? Does it look like we have the most metals, nonmetals, or metalloids? Yeah, we have the most metals, ladies and gentlemen. And then the next would be nonmetals in green, and finally, the metalloids. So let's take a look and see if we can determine which of these are, or whether they're metals, nonmetals, or metalloids. So let's find tungsten. Tungsten is right here. Tungsten is in the yellow category. So what do you think? Do you think that tungsten is a metal, a nonmetal, or a metalloid? Good. So tungsten is going to be a metal because it's sitting right in the middle of this yellow section here. All right, so that's tungsten, symbol W. It's going to be a metal. Let's look at uranium. Uranium is right down here. Element number 92. It's a U. You think that's a metal, a non-metal, or metalloid? That's right, it's a metal. Why don't you try the next two on your own? Krypton and germanium. I'll show you that krypton is right here and germanium is right there. So I'll let you work those out. Perfect, so let's take a look. What'd you come up with? Krypton has the symbol of Kr, and krypton is a nonmetal. And germanium, which is purple, has the abbreviation of Ge, and that is a metalloid. 2 L's. Metalloid. Okay. So now let's start talking about types of molecules and compounds. So what do we mean by types of compounds and molecules? Well, depending on what you mix together, depending on what atoms you mix together, that will make different types of compounds. For example, if you, ladies and gentlemen, have an ionic compound, okay? Ionic compound, yes, you can hear the word ion in there. That's not an accident. Ionic compounds are made up of metals and nonmetals. The cation, or the positive, the metal, gives its electrons to the anion, or the nonmetal. So the nonmetal usually acts as the negative. The metal acts as the positive. So let's take a look. Cations are metal. Anions are nonmetal, generally speaking. All right, nonmetals. And cations are metals. Cations like sodium will lose an electron, thus becoming positively charged. So NaCl, here we go. I just circled it. Na and Cl. So if we take a look at Na and Cl, we can see that Na is the metal and Cl is the nonmetal. We'll have Na is going to be the positive charge because Na is going to give its electron to Cl. Ionic compounds have what's called a transfer of electrons. Transfer. You're going to want to write that one down in your notes. A transfer of electrons, which means the sodium is going to be plus charged and the chlorine is going to be negative charged. The sodium gives its electron to the chloride, and that's why they get along so well. If we take a look at Kf, here's our K, here's our F, pretty much exactly the same as sodium chloride. You'd have the same situation. You'd have the K giving electrons to the fluorine. So the potassium, which has this one electron out here, and fluorine, and this is why they make such great friends, that chlorine, or that potassium, is going to give the electron to fluorine. And when that electron is given away, that makes potassium have a plus charge, fluorine have a negative charge, and then what will happen is these two, since there's a positive and a negative, there's going to be an attraction between them. And that's why they get along so well. If we take a look at sodium, this one has 2 sodiums and 1 oxygen. Metal, non-metal, so you'd have an Na. Mr. P, why would there be 2 NAs? Well, let's take a look. You have those 2 NAs right there, each with its valence electron. And then this oxygen's just hanging out with how many valence electrons? 6. 1, 2, 3, 4, 5, 6. And why would oxygen want to get together with 2 sodiums? Well, oxygen wants to gain 2 more electrons, and voila, that electron's going to be given, which is going to leave us with 2 Na pluses and 1 O2 minus 1, 2, 3, 4, 5, 6, 7, 8. Okay, same thing would happen here with the aluminum. I'm running out of space, but you'd end up with, you have 2 aluminums. All right, those are the metals, and they're going to give their electrons. How many? Well, aluminum is going to have a +3 charge. So each one of these aluminums is going to give 3 electrons to these 3 sulfurs over here. So there are going to be 6 electrons given out. Why 6? Each one's going to give 6. Sulfur is sitting with 6 electrons. 1, 2, 3, 4, 5, 6. And we'll get into this later, but the electrons are all going to balance out, where you'd end up with an Al3+, because the electrons will be transferred. Ionic compounds deal completely with electron transfer. Okay, now we're going to take a look at what's called a covalent compound. A covalent compound is made up of a nonmetal and a nonmetal. Okay, so it's going to be made up of just the greens. All right, covalent compounds are all about sharing. Okay, when the nonmetals get together, they share electrons. I'm not going to get into why or how they share electrons, but they share electrons. So how do you know it's covalent? Because carbon is a nonmetal, right? And oxygen is a nonmetal. And so you'd have these 2 nonmetals, and that would make them a covalent compound. And they're going to be sharing electrons. I don't want to get into it, but I kind of can. Carbon has 1, 2, 3, 4. Oxygen has 1, 2, 3, 4, 5, 6. This oxygen has 1, 2, 3, 4, 5, 6. They want to have 8. They want to have 8. We're going to start sharing all these electrons so that everybody ends up with 8. All right? But again, it's a different lecture. You're just learning right now that nonmetals are covalent compounds. So here we have oxygen. We have 1 oxygen bonding to another oxygen right here, and covalent compound. All right. Now, lastly, we're going to take a look at alloys. Alloys, ladies and gentlemen, are metals and metals. So metals and metals. So the gold wedding ring that your parents have, it's not real gold. It's an alloy. It's made up of gold. I think I put so simple on my hand. Did you guys see that? I'll cut that out. Yes, I will. So let me get back to, I'll cut that. And so the next one that we're going to take a look at, ladies and gentlemen, is going to be alloys. So the alloy is made up of a metal and a metal. So this allows not for sharing of electrons or for transferring electrons, but what's called the sea of electrons, like an ocean of electrons, the sea of electrons. What that is the electrons just get to move wherever they want throughout the metals, which is why metals make such great conductors of electricity. A couple of examples would be brass. Maybe you've heard of brass if you guys have gone out on a boat. They usually have brass on the boat or whatever. But so copper and zinc is an alloy. So they mix a certain amount of copper and a certain amount of zinc, and that makes it. Or maybe you heard of the Bronze Age in your in some kind of a history class. That was taking copper and putting it together with tin. All right, they take these two and make what's called bronze. Or you take stainless steel, which is a lot of silverware is made out of stainless steel. Most of it's iron, right? But then you take a little bit of chromium, which is a shiny metal, nickel, which is a shiny metal. Yes, I know I said non-metals, but usually they'll throw a little bit of carbon in there, but you don't need to know that. The idea is that it's just metals put together. We call those alloys, all right? So now let's just summarize what we've learned today. We're going to determine right now whether or not these are metals or not non-metals or metals, non-metals, metalloids. And then are they going to be ionic compounds, right? An ionic compound, which is, that's right, it's a metal mixed with a non-metal. Is it going to be a covalent compound, which is made up of all non-metals, which would be all green? Or would it be an alloy, which is just made up of metals? So let's take a look. O3, do you think that's going to be a covalent compound, ionic, or alloy? Well, let's take a look. Oxygen is in the green category. So oxygens are all non-metal. And since the oxygens are all non-metal, it's 3 oxygens in there. 3 oxygens all stuck together. It's this molecule. It's shaped like a little pyramid. But the 3 oxygens, all right, are all together. So that must make this a covalent compound. Good. Let's take a look at the next one. We have uranium, which is element 92, and fluorine. Do we think that uranium and fluorine are going to make ionic, covalent, or an alloy? Well, let's see. Uranium's a metal. Fluorine is a non-metal. And if you mix a metal and a non-metal, a yellow with a green, that's going to make an ionic compound. So this is going to be an ionic compound. Number 3, we have carbons, hydrogens, and oxygens. Let's take a look at, find our carbons, our hydrogens, and our oxygens. So let's see, there's a carbon, there's a hydrogen, which is green, and an oxygen. What do you guys think? Well, carbon is a nonmetal. Hydrogen is a nonmetal. And oxygen is a nonmetal. So this is a compound made up of all nonmetals. This is ethanol, all right? This is what you find in alcohol. A very, very common organic compound. So those are all nonmetals, which means this one must be covalent, all right? This last one, we have potassium. So let's find potassium. So potassium's right over here. We'll put these in, it's in green. We have potassium right here. All right, so potassium looks like, probably shouldn't use green. Let's get rid of that because that's one of the colors. We'll just go back to red, I reckon. So we have potassium, which is a metal. And then we have manganese, which is a metal. And then we have oxygen over here, which is a non-metal. What kind of compound is that? Well, we have metals mixed with non-metals, which is going to mean we have an ionic compound. Yellows mixed with greens, right? Covalent compounds, all the green ones. Alloys, the yellow ones. Ionic compounds, yellow mixed with green. So it's just mixing and matching things in the periodic table. So, ladies and gentlemen, I will be here to assist you as you're working on your video lecture today. So let me know if you need anything. I'll be here.